Hello world, I'm Sol Problemo, and today it's the seventh problem of programming skill study set from Leetcode, and today's problem is +1. Let's get started. So what we have here, you're given a large integer represented as an integer array digits, where each digit I is the ith digit of the integer. So the digits are ordered from most significant to least significant in the left-right order. So basically what we have here, we are given an array digits where each element is one digit of a non-negative integer. So in most significant digits first. And of course, the integer does not contain any leading zero. So we won't see some zeros in the examples at the beginning. So, and basically, yeah, this is the example. As we have digits and arrays 1 to 3, means the number is 1 to 3, so 123. And we need to add 1 to that number and return the resulting digits. For example, if we have array 1 to 3, we will return 1 to 4, which means we have 123. We did addition with 1, and it would be 124. And if it would be, yeah, and the main problem here is when we have a 9, we have to return 10. So it should be 1 and 0. And also, if it's 999, the next one should be 1000. So it should return one array of 4 elements instead of just 3. Yeah, basically this is it. Before we dive into solving this problem, what I always do is ask some questions, and first question, as always, is what constraints tell us. The constraints that we have here is that digit length is between 1 and 100, means the number can have up to 100 digits. Then we have the element, each element of this array is between 0 and 9, which means every array element is guaranteed to be a valid single digit, and we never have to deal with invalid values like 12 or -3. And digits, as I said before, does not contain any leading zeros. It means that we don't need to worry about some weird inputs. So this is actually the main question that I have asked myself. And the next is what I do also to so all these problems somehow will stuck in my head. It's think of a real world case scenario, and in this case for the +1 problem, I have the example that come to my mind is rolling over an invoice, or you can call it transaction ID in a finance system. So for example, banks, payment system, or an accounting software often generate some sequential IDs for things like invoices, payments, receipts, or transaction batches. So sometimes these IDs are so large and they are stored digit by digit. So we treat them as an array of digits. And for example, yeah, digits might be like this one. Of course, yeah, the leading zeros could exist in some formatted display, but internally now in this problem, we are not gonna, we assume that we have no leading zeros. Probably this is it, but the logic is the same. And what we have to do now, issue is the next invoice. And we just have to do +1, so to see the next invoice. And probably this just change like an odometer in some cars. And for example, as 9 becomes 0, and we have to carry to the left, then next 9 becomes also 0 carry, and 2 becomes 3, and we have to stop. And so if we want to do this, we just have to think of something. So this is the real world case scenario. So, and to solve these problems, we have probably, of course, we have a lot of possible solutions, but the easiest ones is first we are gonna simulate addition with carry. It's kind of as we have learned some addition in school, as we have when we do by some when we add something, and if it's comes to the adding 9, we have to carry a number. So what's the idea of the solution is we add 1 to the number starting from the last digit. So if the last digit is not 9, we just add 10 and we are done. Yeah, everything is good. As here, for example, if it's 1 to 3, in the last digit, if it's not 9, not more than 9, I mean, it's not 9, so we just do an addition, and it would be just 4, and we return this. Basically, this is the easy case, and in the worst cases, we have 9, and we have to deal with it. And how we do it, as in school, if the last digit is 9, it becomes 0, and we carry 1 to the left, and then keep going left while there is a carry. And if we carry it past the first digit, like 999, we need to add a new digit 1 at the front. So how it would work, this is example is possibly an easy one. Then we have, for example, 129, and last digit is 9, so it becomes 0, and we carry 1 until so we move left, then we have digit 2, and we do plus carry, and this so it was 2, and we carry 1, and we add to this digit the thing that we carried with us. So, and when carry stops, we have 130. But for example, the hard case, so this is the worst case, that we have 999. It means that we will go from the end of the array, and when we come from left to so from right to left, it's I don't know how it's called, from the last digit to the front, we will just then carry 0 0 0, and in the end, when we will return the array, we just add 1 to this. So complexity of this solution would be on. So in the worst case like this, we touch every digit once, and space in the Python, it would be on. Only in the special case when we create a new list, it would be on as plus 1 plus digits. And for in C++, it would be a constant, possibly almost, but inserting at the beginning can shift elements, so still overall on work possibly. So, but in typical complexity discussion, we could say that it's on and extra space is constant, or sometimes if counting the new output array, it would be on. So basically, this is the probably the best solution for this case. I don't know, for me. But we have one more thing that we have to think of, is possibly we can convert to int. So we can convert this array to the int, to the number as 1 to 3, just then do some operations, addition, and it would be 1 to 4, and then back we have to return it to the array as 1 to 4. Basically, this is also the good solution you might think of, and the complexity would be almost the same, as time would be on and the space would be on, as we have to create a string of length n, then we a big integer representation, then we have another string for output, and we would output the least length of n. So yeah, of course, it's more memory overhead than the carry approach, but still, it's also something that we can think of. But why it's not recommended, even if it works in Python, as Python deal with some big numbers. For example, in C++ or Java, the number can have up to 100 digits, so which does not fit in standard integer types of this programming languages. And so this approach fails unless you, of course, use some big integer libraries or anything else. But it avoids the point of the problem, as we have to the task is designed to test if you understand digit by digit addition and carry handling. So yeah, so basically the simulate addition with carry solution is better than this. So yeah, let's then write the code for the solution and think that we are done with this problem. digits. So basically, this is the solution. And what we do here, let's check it. So yeah, the past. So probably what we have here, we have to first define the length of the digits, the number of elements that we have. Then cycle will go to from the last element of the array and go to the front, so from right to left. And then if digits is less than 9, we increment the digits, just as in the case when we have 1, 2, 3, and we will increment it by 4, for example. Yeah, just as the case, and we return these digits. But if it's not less than 9 and it equals to 9, for example, we will move like this to the 0, and then we will carry the 1, and then we will just add 1 to the next element of the digit. So basically this is it. And if it would be like this, we'll just do 0, 0, 0, and we will add, as here we add 1 at the front of the array. This is the solution. So basically we have solved 7th problem of programming skill study set, and see you tomorrow.